Hello, this is Mr. Huber. Let's study linear functions and the slope-intercept form of linear equations. One of the key pieces to any line is its slope. The slope of the line is its rise over run. Think about rise, that's along the y-axis up and down, run left and right along the x-axis, so we want to find how much our y values are changing for the rise and how much our x values are changing for the run, and write it as a fraction. And oftentimes keep it as a fraction. We don't need to turn it into a decimal or anything else like that. So we're going to have 2 points that are anywhere on the line, and we can find the slope of that line. Here's some examples. Okay. So for this first line, it goes through the points -4, 2 and 2, 6. This would be our x1, y1, and this would be our x2, y2. And so you can see then we subtract y2 minus y1, that's the 6 minus 2, and then we subtract x2 minus x1, 2 minus -4. Keep in mind, 2 minus -4 is 2 plus 4. So 6 minus 2 gives us 4 over 2 plus 4 is 6. So the slope of that line would be 4 over 6, or we could reduce to 2 over 3. We can just keep it as a fraction. One important thing to point out here is, what if we switched those around and we called the 2, 6 our x1, y1, and this is our x2, y2. If we find the slope that way, y2 minus y1 would be 2 minus 6. x2 minus x1 would be -4 minus 2. That would give us -4 over -6. A negative over a negative would be a positive, and then we could reduce as well to 2 over 3. It would give us the same slope. So you can call either point your x1 and y1, and the other point your x2 and y2. It doesn't matter as long as you're consistent. We're not going to make, for instance, this point right here, we're not going to make this x1 and y2. That won't work. If this is x1, this is y1 that goes with it. If this is x2, this is y2 that goes with it. So just be careful there, but it doesn't matter which one you call your first and second point. Okay. In this next example, we got the points 3, 5 and 6, -1. So again, we do y2 minus y1 over x2 minus x1. So subtract the y values or subtracting the x values, rise over run, and we get -6 over 3, which we can reduce to -2. Keeping it as a whole number like that is fine, or an integer I should say, -2, so that's an integer. You could leave it as -2 over 1, that's fine as well. Okay. Keeping in mind what we do with a fraction when we have negatives in there, in this case we had a -6 over +3, that's a negative slope. In the example before when we did the second version, we had a negative over a negative, that's a positive. So again, we want to remember that when we have a negative over a negative in a fraction, it equals a positive. Right. Let's look at a couple special cases here. Okay. So in number 3 we see here, we have -2, 4 and 7, 4. When we do the slope y2 minus y1 over x2 minus x1, we get 0 over 9. 0 divided by anything is 0. That's a horizontal line. Okay? If we were going to graph those points, we'd have -2, 1, 2, 3, 4. -2, 4 would be like right there. And then 1, 2, 3, 4, 5, 6, 7, 4 would be right here. And if we draw a line through those, that's a horizontal line. That would be the line where all the y values are equal to 4, right? This is 4 on the y-axis. So that's a horizontal line. A horizontal line will always have a slope of 0. The other instance you see below that, in the fourth example, is a slope that's undefined because you have a 0 in the denominator. Okay? Notice the difference where we have 0 in the numerator here versus 0 in the denominator here. 0 in the numerator divided by anything is 0. In this case, we can't divide by 0. That's mathematically undefined. And that would be a vertical line. Okay? If we go to that same kind of graph right over there, if we do 3, 5, that'd be a point right about there. And then 3, -1, right about there. And if we draw the line through those, we have a vertical line straight up and down. That will have a slope that's what's called undefined. So know the difference between a 0 and an undefined slope. So when you see those, you're able to work with them and know what the graphs look like in terms of those horizontal and vertical lines as well. All right, a little sports trivia, if you will. We got the ESPN theme there, da-da-da, da-da-da. And what does it stand for, right? When ESPN was founded in 1979, believe it or not, they did not think that they would be able to do 24 hours of sports on a channel. So it was ESPN for the Entertainment and Sports Programming Network, so that they could put things on that weren't sports related, because they really didn't think they could fill a full 24 hours with sports. Little did they know how that would blow up, and now we've got so many sports channels, and one's for each specific sport themselves. So it's really blossomed from there. But back in 1979, putting on a channel that was 24 hours of sports was unheard of. All right, so Entertainment and Sports Programming Network. Let's talk a little more about the slopes and the y-intercepts of lines and how we can use those to graph the line. Okay, when we see a line written in the equation y equals mx plus b, okay, which we see right here, y equals mx plus b, that's called slope-intercept form. The m is the letter that represents slope. The b is the letter that represents y-intercept. That's why it's called slope-intercept form. Okay, slope-intercept form uses the slope and the y-intercept. The y-intercept is the point where the graph goes through the y-axis. This point right here is the y-intercept. In this case, it's a 1. Okay, and the slope, 1 over 3, because the graph rises 1 and runs 3. Rise over run for the slope. Okay, so this is what it looks like in words, slope-intercept form, when we write the equation, and then what it looks like on a graph. And we're going to now look at how to find slopes, intercepts, draw the graphs, work with the equations for their graphs. One of the keys is you have to solve the equation for y as a function of x. You have to get it to be y equals y all by itself. Okay, that's how you can find slope-intercept form. So sometimes you have some work to do to get slope-intercept form written, and then you can work on the graph from there. So in this first example, y equals 5x minus 3, it's already in slope-intercept form. We've solved for the y already by itself. So if we want to identify the slope, the m is 5, and the y-intercept b is negative 3. In the next example, we're going to have some work to do. Okay, we want to get y by itself. We can subtract 3x on both sides. We have negative 3y equals negative 3x plus 12, or 12 minus 3x, that's the same thing. Divide by negative 3. Don't forget to bring this negative sign down here. Divide everything on the right side by negative 3, also important. We're going to get y equals negative 3 over negative 3 is a positive 1x. 12 over negative 3 is negative 4. So our slope is 1, our y-intercept is negative 4. And in our next example, again, to get the y by itself, we subtract x on both sides first. We're going to have 4y equals negative x plus 6. And now we need to divide everything by 4. And to get the y by itself, we'll have y equals negative 1 over 4x. Right, there's a 1 in front of that x, a negative 1 in this case. And then plus 6 over 4, which you could leave as 3 over 2. Or if you turn that into a decimal, that's okay. It'd be 1.5. All right, so our slope would be negative 1/4. Our y-intercept is positive 3 over 2, or 1.5. It's the same thing. Right? So being able to solve an equation for y is really important here. Okay? That's when you have slope-intercept form and you can figure out what your slope and your y-intercept are, which are essential to being able to graph these equations. Right? Let's see what it looks like then to graph one. So if we want to graph this equation, the first thing we need to do is get the y by itself. Solve this for y. So if I add 3x to both sides of my equation, I'm going to get y equals 3x plus 4. So I've got my slope is 3, my y-intercept is 4. When I graph that, my x-axis and my y-axis, okay, the first thing I'm going to do is plot the y-intercept. I'm going to take this point and put it on the y-axis right here. Okay, right at 4 on the y-axis. Again, that's the y-intercept. And our slope of 3, that's like 3 over 1. So from this point that I have right here, I'm going to count up 3. 1, 2, 3. That's my rise of 3. And then I'm going to run 1. I'm going to go over 1. And at this point, that's where I'm going to put another point that I know is on my line. Up 3 over 1, and I've got a point right there. And now I could draw my line through those points. Okay? I could draw a line that goes through those points, and that would be the graph of the equation y equals 3x plus 4. Okay? So plot your y-intercept, use the slope to get a second point, and then draw your line through them. Put arrows on both ends. Draw a nice, neat graph, right, so that it looks organized and makes sense. Look at one more example here. A little more work to do to solve for y, so let's do that first. Okay? We're going to subtract 2x on both sides. And we're going to get negative 5y equals negative 2x plus 10. Then we're going to divide by negative 5 on both sides. There's going to be y equals negative 2 over negative 5, so a positive 2 over 5x. 10 over negative 5 is a negative 2. So when I go to graph this, again, first thing I'm going to do is identify my slope, 2 over 5, my y-intercept, negative 2. I'm going to graph that y-intercept first. X-axis, y-axis, I'm going by 1s on both axes, so I'm going to put a point at negative 2. Then I'm going to count my rise and my run. Remember, I want to go from this point, start from the y-intercept, and then rise 1, 2, because this is our rise 2. Then run 5. So I'm going to go up 2 and over 1, 2, 3, 4, 5. And right here is where I'm going to put another point. So I can put another point at this spot right here. Right? I went from my y-intercept up 2 and over 5. This would be the same as negative 2 over negative 5. So how would that work? What if I had a negative 2 over negative 5? Well, then I would go from this point down 2, because the rise is negative 2. That means we're going down. And a negative 5 for the run means I'm going to the left. 1, 2, 3, 4, 5. I'd have a point right here. So I could put that point there. Okay. You can notice they're going to be on the same line. It wouldn't matter which of those I have, and sometimes it could be good to draw more than 2 points. So your line can be even that much more accurate, and I can draw a line through those points. And that would be the graph of the line that we started with, 2x minus 5y equals 10, which we turned into slope-intercept form, y equals 2 over 5x minus 2. Again, so know how to solve for y, and then how to use that slope-intercept form to draw the graph. Clearly, slope's important here, y-intercept's important. Know how to calculate slope, know how to use slope, know how to use the y-intercept, and what those things mean in terms of the equation. And we'll be doing some more work with some linear equations. And to keep you going on that, right, this is kind of a general guide for reminding you how to graph an equation using slope-intercept form. Those are the steps I kind of went through. You can use this as reference if you get stuck. Remember to solve for y, identify slope and y-intercept, and then how to graph it and have a good equation drawn, or excuse me, a line drawn for whatever your equation is.